In this video, tragedy has struck. There's been an earthquake in California, and the quad at Stanford has completely fallen apart. It's going to be Carol's job to actually go around the quad and fix some of the columns that have fallen apart after the great earthquake. So we're going to be coding the RepairQuad Carol program together. I'm going to open this up, and as always, I'm going to go ahead and run it. And this is going to be one of the ones where we actually need to load in the world. So let me go ahead and do that. There's actually two different types of quads Carol might be repairing. This is what quad 0 might look like. And you can see here, this kind of looks like a building. And what these are supposed to be is columns of beepers. Now, as we're getting into more and more complex Carol problems, I really want you thinking about what are some of the things that are guaranteed about these problems. For example, when we were doing the mountain climbing program last time, it was guaranteed kind of the format of the mountain, but we didn't know how tall the mountain was going to be, and we didn't really know where it was going to be in Carol's world. So there were some things that were guaranteed and some that weren't. In this case, I want you kind of already asking yourself some questions like maybe, do we know how many columns there's going to be? Do we know how tall those will be? Do we know where beepers are going to be missing from the columns? Let me answer some of these questions for you. We are always going to have columns that are spaced 4 apart. So you can see that every 4 spots, there's kind of 1 column, 3 blanks, 1 column, etc. So that's always going to be the pattern. There's always 3 empty ones in between. How tall the columns are, in this one, it actually looks like they're always 5 tall. But if we actually look at the other quad world, you can see that the height of each column can actually vary somewhat. Here, there's a column that's 3 tall. Here, this one will be 5. This one's actually just 1 tall. So you can see we're going to have to make the kind of column height work for every possible instance. I'm going to change this back to the kind of standard quad world. The number of beepers missing in every single column is also going to be something that's variable. You can see that there's beepers missing in different places all over the columns. And how many columns there are is also going to be something that's variable. In this case, there's 4. Actually, also in the other one, there's 4, but that's not always a guarantee. We could hypothetically have a quad that's a little bit longer. As we're going into this, let's be thinking we are going to be using a lot of top-down design here. I'm going to let you know now too, I am going to make a mistake for learning purposes kind of throughout this. Sometimes I'll make mistakes in these examples that I don't need to, and I'll try to pass them off as if I made them for learning purposes. But I'm going to tell you straight up, I am going to make an intentional mistake in here. So if you're already kind of noticing it as we start going through, just hold on. I promise there's a point and I will fix it at the end. Let's go ahead and thinking in terms of top-down design, let's think about how we are actually going to solve this problem. What's actually happening in the grand scheme of this? What is Carol going to be doing? Well, it seems like over and over again, Carol needs to fix a column and then kind of move on to the next column. And like I said at the beginning of this, we don't actually know how many columns there will be. So when do we know we're done? Well, we kind of know we're done when we're at the end of the world here. And when we know that at the end of the world, that means our front will now be blocked, which means that we want to keep fixing columns while our front is clear. So I'm going to start with a while front is clear. Let's first fix a column. And then let's move to next column. And I would argue that one of these tasks is way easier than the other. I think moving to the next column is pretty simple. So let's do that first. Let's do public void move to next column. And I did say, if you remember, that these columns are always going to be equidistant apart. So I do believe it takes me 1, 2, 3, 4 moves to get from one column to the next one. Now I could just put move 4 times, but we want to keep practicing our different control structures. And we know if I'm trying to repeat something a certain number of times, I can actually use this for loop here. So let's just practice typing a for loop. We're going to type for int I equals 0, semicolon. I is less than 4 because I want this to happen 4 times. semicolon, I++. And all that's going to go in here is just a move method. Sweet. So it seems like we're halfway done. Not quite. Let's go public void move to next column. And just to remind you too, I do think I've mentioned this earlier, but it is a pretty common Java convention that I'm kind of typing all of these methods the way that I am. I could have just named this in all lowercase, or maybe I could have put underscores in the middle, but we're going to get in the habit of doing this. This is something called camel case, where kind of the first letter of the first word is lowercase, and then every other letter after that is uppercase. This is just kind of a typical Java thing that people do when they're coding in this language, and we're going to stick to that in this class. All right. I'm also now realizing I accidentally put move to next column here, which we've already coded. This was not the intentional mistake. Let's do fix column here. So how do we fix a column? Well, there's kind of two things that we have to do to fix the column. The first is we have to ascend column replacing beepers. And then we have to go down column. And you might be looking at that being like, that is the most ridiculous method name I've ever seen. But nobody is going to mistake what this method does. I do think that it is a little long, yes, but it is so incredibly descriptive. So let's write public void ascend column replacing beepers. And you could just copy paste that. So I think the very first thing I have to do when I'm ascending the column replacing the beepers is, don't I have to actually turn left so I can go up? So let's turn left. Then I did say at the beginning that we don't actually know how tall this column is. So we don't necessarily know how many times we want to kind of move, replace a beeper, move, replace a beeper, right? So in this case, I do think that instead of a for loop, we're going to have to use a while loop here. So let's do while. And I should be done replacing beepers, right? Once there's a wall in front of me. I want to keep replacing beepers while my front is still clear. So let's do while front is clear. And then let's do replace beeper if needed. I don't want to just do a put beeper there because I don't necessarily know if I need to put down a beeper. There might already be a beeper there. And then let's do move. So we have kind of two more methods to write. We've got replace beeper if needed, and then we eventually have to write go down column. Let's do public void replace beeper if needed. Now, when we're doing this, we're actually going to use one of the control structures we haven't quite used as much. And that's going to be our if statement. I want you to think a little bit about why an if statement would come into play here. Think about the name of this method. We're replacing a single beeper if needed. I'm not doing some task repeatedly. It's something I actually just need to check once. When do I want to replace a beeper? If there's not already one there. Let's take a look at our Karel one-pager, and I want you to just look at the sensory conditions. I think there's one that we haven't used yet that's going to be useful in this case, which is that when do I want to put down a beeper? When there's actually no beeper already there. So let's do this. Let's do if no beepers present, let's put beeper. And I want this to be an if statement, not an if else statement, because the else is kind of just, I don't need to do anything, right? So the else is a little bit redundant there. I don't actually need it. I think the last method we have to write is this go down column up here. So let's do public void go down column. Oops. Now remember, kind of at the end of Karel going up and replacing all of these beepers, they should be kind of right here at the top facing up. So I first need to kind of turn Karel around so they're facing the ground. So let's do 2 turn lefts. Now I'm facing the ground. And then don't I want to just kind of move while my front is clear? So let's do while front is clear. Let's move. Now Carol should be kind of on the ground, facing the ground, almost like, I like to think of this as that like, kind of like Mission Impossible. You're kind of rappelling down from the ceiling to grab some treasure in the museum or something like that. So now Carol's facing the ground. Carol needs to be kind of facing this direction. So I think we have one more turn left. And let's see if this works. Keep in mind that I did say that there was going to be an intentional error here. So you might be thinking this probably won't entirely work. But let's see what this looks like. I'm going to run this. Let's load in quad 0. And let's start. So it looks pretty good at first until you realize Carol actually missed a little bit there. And I'm going to reset this because I want you to kind of pay close attention to what Carol is kind of missing right now. So I'm going to start this again. Looks like we do the first column okay. Looks like we're missing the top beeper on the second column, and kind of looks like we actually didn't do the last column at all. There is something that is going on here. And this is something that happens actually a lot in computer science. It happens so frequently that it actually has a name. And that name is called a fence post problem. So let's think about what's actually happening here. Big picture, let's go look at our run method. What am I going to do over and over again? I'm going to fix a column, and then I'm going to move to the next column. Well, how many columns do I have here? I have 1, 2, 3, 4. How many times do I need to move between columns, though, is 1, 2, 3. Do you see where the problem's coming in here? Let me kind of explain what I mean by the fence post problem. So this fence post problem is this special type of problem where you might be looping or doing something repeatedly, and you actually want to do something an extra time. In this case, I have 4 fixed columns, but only 3 move to the next columns. So if I'm repeating them like this, that's going to be an issue because I'm going to do them an equal number of times. If we actually think about how a fence looks, right? Like a regular fence you would see in real life, isn't it kind of like there's a post, and then there's some fence, and then there's a post, and then there's some fence, and then you can keep going post, fence, fence. And what do you actually end with is an extra, that was a weird post, an extra post. And that's kind of what's happening here. Fixing a column is our post. We actually need to do this an extra time. Moving to the next column is our fencing in the middle. We don't need to do this as much. There is a really easy solution for the fence post problem. To start though, I want to talk about one thing. Your first instinct might be, well, what if I just switch the order of these, right? If I switch the order of these, I will now get the last column because I'm definitely ending with fixing a column, but I'm actually going to miss the first one. So that actually won't solve the fence post problem. But you know what will is all I need to do is add an extra post at the end. There we go. And this actually will now fix the last column. Let me go ahead and compile this and let's run it. Let's load in our world. Now keep in mind, we haven't fixed everything yet, but we've fixed a decent amount. Let's start. I'm still missing that top beeper there. Now I do fill in the last column, but that top beeper, that might seem like it's actually a different fence post problem. Let's think about what's happening when I'm actually filling in my column. Well, here's my fixed column. It's probably happening when I'm ascending the column, replacing the beepers. Let's think about this while loop. While my front is clear, I'm going to replace a beeper if needed, and then I'm going to move. Let's think about how many times each of those things need to happen. There's 5 beepers in every column, but there's only 1, 2, 3, 4 moves. So replace beeper if needed, that's my post, and move is actually my fence. And remember, how did we say we just solved the fence post problem? We actually just added another post. You might have been wondering why I actually made this a method, given that it's really only 2 things, but didn't that come in handy now? Because all I had to do was call that method. Now, in both of these instances, I did add the extra post after. I could have also done things this way where if inside the while loop I kind of had things in that order, I could have done the extra post at the beginning. That would work too. I just want to show you kind of both ways. So now you know and you've seen this fence post problem that we talked about here. And what's always the solution to the fence post problem? You need to add an extra post, either at the beginning or the end, depending on the order that you did things in. Next time we are going to do another Karel program, surprise, surprise. Before we actually do that, I am going to show you a little bit of Java stuff in a program called Clean Stairs. So I will see you in the next video.